Solving systems of two linear equations in two unknowns algebraically, we'll see two methods, one by substitution and second by elimination. Let's start with method of substitution first. Step 1. We solve for one of the unknowns. So we reorder for one of the unknowns from one of the equations. Once we have that, we substitute this solution into another equation. So now we only have equation with one unknown. Then we simplify the equation and solve for the unknown it contains. So now we have a solution for one of the variable. Then we substitute that back into one of the initial equations, and see what we get for the other unknown or variable. Once we have solution for both variables, we check them in the original equations to see if our solution is correct. Example. Let's say we have x minus 3y equals 1 as equation number 1 and 2x plus 5y equals 2 as equation number 2. This is what we start doing. What we do here is from equation 1, we can say x equals 1 plus 3y, and then what we can do here is we can say then substitute that into equation 2. We get 2 times, instead of x now I'll say 1 plus 3y plus 5y equals 2, which then will give us 2 plus 6y plus 5y equals 2, which then will give us 11y, and subtract 2 on both sides will be 11y equals 2 minus 2. So then the y will be 0 divided by 11, which will be then y will be 0. Now we have y equals 0, so we'll substitute y equals 0 into any of the equations. So let's say into equation 1. What we get now here is x minus 3 times 0 equals 1. Simplifying this, we get x minus 0, which is x, equals 1. So the solution here is we have x equals 1 and y equals 0. Now to check, we put back x1, y0 in here. So 1 subtract 3 times 0, which will be 0. 1 subtract 0 will be 1, and right side is 1. So it works in the first equation. Now for the second equation, we do same thing. We substitute x equals 1, y equals 0. So we have 2 times 1, which is 2, plus 5 times 0, which is 0. 2 plus 0 will give us 2. So that works. Meaning that this solution is correct. Let's look at another example. Now I have 2x plus 3y equals 0, 4x plus 5y equals 2. It's not easy to not like other one where we can say x equals something. Here now I have 2x. So you have two options here. One thing you can do is you can simplify your 2x. You can say 2x equals negative 3y. And once you have that, you can say x equals negative 3y divided by 2. So you'll have fraction. Or if you want to avoid fractions, what you can do here is you can just simplify from equation 1. Just going to simplify for 2x, not for x. So I'm going to say from equation 1, we can say 2x equals negative 3y. Once we have this from equation 2, then I can say I'm going to write equation 2 like this. Instead of 4x, I'm going to claim 4x is same as 2 times 2x. So I'm separating 4x little bit, plus 5y equals 2. Now instead of 2x here, we can claim that it is same as negative 3y, because that's what we have from equation 1 here. So I'm going to replace 2x. So I'm going to substitute 2x as negative 3y. So I have 2 times negative 3y plus 5y equals 2. What we get here is then negative 6y plus 5y equals 2. So we get So we get negative y equals 2. So then we can claim that y has to be negative 2. Now that we have y equals negative 2, we can substitute this into equation 1 or 2, does not matter which one. Substitute this into, let's say, equation 1 for example. We will get 2x plus 3 times y, which is 3 times negative 2, equals 0. So then we can say then 2x minus 6 equals 0. So we can say then 2x equals 6. Divide both side by 2, we get x equals 3. So therefore the solution is x being 3, y being negative 2. Now to double check this, we can put 3 and negative 2 here. So x being 3, y being negative 2, we have 6 minus 6, which is 0. X being 3, y being negative 2, so 12 minus 10 will be 2, so that solution is correct. So this is method of substitution. Now solving two equations, two unknowns using method of elimination. These are few steps we follow. First, we reorder our equations in the form looking like this. We have to have x's underneath each other, y's underneath each other, equals constants without the variables. Then what we try to do is either make same number of x's or same number of y's. Signs can be different, so we can have both same number of x's but opposite sign, or we can have same number of x's with same sign. So if I had one equation with 2x, I would like to make another equation with either 2x or negative 2x. If it is both same sign, so 2x and 2x, we'll end up subtracting equations from each other, because 2x minus 2x will eliminate x. As the name suggests, method of elimination. If they had opposite sign, positive 2x and negative 2x, then we will end up adding equations so that 2x minus 2x will be 0x, eliminating x again. Now that we have one variable eliminated, we simplify the equation and find solution for the other variable. Once we have solution for that variable, we go back into one of the original equations and solve for the second unknown. Now that we have solution for both unknowns, we'll go back and check our solutions in the original equations. Let's see example here. Let's say I have x plus 3y equals 7, 2x minus 3y equals 5. Either you try to make them same number of x's or same number of y's. In this particular case, we already have same number of y's. Now sign wise, because we already have opposite sign, we will add our equations. So we will say add them. So when we add, x plus 2x will give me 3x, 3y plus negative 3y will be 0, and 7 plus 5 will give us 12. So now we have 3x equals 12. Divide both sides by 3, we will get x equals 4. Now that we have solution to one variable, we will substitute that into any of the previous equations. Substitute into, let's say, equation 1 for example. We will get 4 plus 3y equals 7. So then we can say 3y equals 7 minus 4. So we get 3y equals 3. That means then y equals 1. So the solution here will be x being 4, y being 1. Now to check this, we will put 4 here for the x, 1 for the y. 4 plus 3 will be 7. 8 minus 3 will be 5. So that solution works. That will be verification of that solution. Let's see another one. Now I have 2x minus 20 equals 7y, 3x plus 5y equals negative 1. We have to be careful here. In this method, we need to have x's underneath each other and we need to have y's underneath each other. So what we'll end up doing here is the first equation we'll have to reorder. So 7y going to the left or subtracting 7y from both sides, we will get 2x minus 7y equals, and adding 20 on both sides. This will be our new first equation. It is basically reordering the first one. Now we have x's underneath each other, we have y's underneath each other, and coefficients on the other side. Now we want to make them same number for either x's or y's. So 2 and 3 here. So common number in which 2 and 3 both goes into is 6. So we'll end up multiplying first equation, entire equation with 3, and second entire equation with 2. Okay. You could pick y as well. You can multiply first equation with 5, second equation with 7, and make both y's become 35. It is your choice. So by doing this, now my new equations becomes this. It will be 6x minus 21y equals 60, and 6x plus 10y equals negative 2. Now that they both have 6x and 6x both have positive values, both are same sign, we will subtract this equation. So subtract, we will subtract this equation. So I'll just put a negative sign here to show that we are subtracting them. So 6x minus 6x will be 0, and then negative 21y subtract 10y will be negative 31y equals 60 subtract negative 2 will be 60 plus 2, which will be 62. Now that we have this, divide both sides by negative 31, y will end up being negative 2. Once we have solution for y, we can substitute y equals negative 2 into any of the equations. So I'll say, let's say in the first equation, we get 2x minus 20 equals 7 times negative 2. When we simplify this further, we will get 2x equals negative 14 plus 20. So we get 2x equals 6. So x will be then 3. Divide both sides by 2, we'll get x equals 3. So then the solution is, for this equation, x equals 3, y equals negative 2. So let's put 3 for the x, y to be negative 2, see if it works. So putting x here to be 3, substituting, we get 2 times 3 to be 6, minus 20, so left side is negative 14. Right side then, 7 times negative 2 will be negative 14. So it works in the first equation. We have to check for both. So for the second one then, if I put 3 here, 3 times 3 is 9, plus 5 times negative 2 will be negative 10. 9 minus 10 will be negative 1. So it works here too. So the solution x equals 3, y equals negative 2 works in this system of equation. This is method of elimination because we are getting rid of one of the variable.